Hey, just wanted to make a few comments on the videos that you saw, and just to clarify, especially with electromotive force and what's going on in a battery. So in this diagram, you can see I have a battery set up, and then it's going around through a resistor, and then coming back into the other side. Although we know that the electrons actually flow in this direction, we're talking about convectional current. So our current flows in this direction. So that's our I. Okay, this device here, this is a voltmeter. This measures potential difference. And what we want to talk about is like, what's the potential difference across the battery? And Dr. Levin talked about this in the video. So the potential difference of the battery would be the A minus B, or B minus A, it doesn't matter, whichever way you take it. And so it's the potential difference created within the battery. And so it gets a little bit confusing, because if you watch the videos on how batteries actually work, the electrons don't actually move. There's that barrier in between them. And what we're doing is we're depleting them. We're sending them away. Let me see if I can draw one. So something like that. So there's this barrier in between it. And what's happening is all of our electrons are flying out of this side. They come back around to the positive terminal, where they then get absorbed into this material on the outside. And then once all those electrons have moved, the battery's dead. So that's how they work. But when we think about it, we're thinking about like a charge or a current actually moving through the battery. And there are wet cell batteries where that does happen, and that's what Dr. Lewin was showing you, like in a car battery. And so what we say is that the amount of potential that the battery can instill, that's what's called the electromotive force, although we don't use that anymore. So we just say that that's EMF. So I may still say it occasionally, but just know that it's going away, because it's not a force. We're not talking about forces. So most textbooks and I don't know, instructors are starting to move away from the idea that it's a force. So we just say EMF, and it's the script kind of E for the EMF. And what we find is that these are the same. So the potential difference of the battery is the EMF. So for a standard battery that you buy, it's going to be 1.5 volts. That's going to be the EMF of the battery. Now, when you actually have it hooked up in a current, your potential difference across here is going to be less. It can be less than the EMF, because that's the amount that it could have, not that it necessarily does. Okay, so just wanted to clarify some of that, and that's it.